Okay, welcome to the second day of dual credit finite. So hopefully y'all had a good first day and a good second day. Uh, we're almost done with the second day at this point. You're in fifth period. So let's get on with it, and then that way, the sooner we get done with the video, the sooner you get to do your assignment. Okay, so just a few reminders. If you haven't signed up for Google Classroom, or like accepted the invitation, please be sure to do that as soon as possible, because that's where you'll be able to access, for now, the assignments. I haven't posted the one for today yet because, quite frankly, I haven't built it yet. I have the assignment, and it'll be the same as the handout that the sub has given you, but I haven't built the assignment yet. So it will be built though, and by the time you're seeing this, it'll be done. And it'll be posted down here under Unit 0. You'll look for something that says like Section 0.1, where we're going to look at what's called the real numbers today. But you'll want to go into that, and that'll take you to something called Edgelastic. Now, if you had me for geometry or maybe stats, you're probably already familiar with Edgelastic. If you aren't, then you'll click a link in Google, it'll ask you to go sign in. So I'll show you from the stats perspective what it looks like. It'll be down here, it'll have like a little homework symbol, and it'll say, yours would say section 0.1, the real numbers. And then click it, you'll click the link that says peer assessment, and you'll log in with your Google School login. And it'll ask you to accept some permissions. You'll have to accept those, and then it'll take you into the assignment. So, but to do all of that, you have to be into Google Classroom. So make sure you get that done if you haven't already. With that said, the first thing we're going to do is peer grade the prerequisite skills test that y'all did yesterday. Many of y'all may not have finished it. That's okay. But the sub will pass them out randomly. When you get yours, or not yours, but when you get whichever one you're going to grade, on the front bottom part, I want you to write graded by and then your name down here. Graded by and then your name. So this, you won't be grading your own, you'll be grading a classmate's. What I'm going to do today is just go through and say, these are the answers. When I get back on Monday, if you want to look at your test like in detail and see, oh, I thought that was right and it's not, or whatever the case may be, we can do that when I get back. But for now, we're just going to grade the answers. And don't worry at the end of, well, I'll get to that when we get there. But anyways, we're just checking the answers right now. So the first part, they want you to find the most simplified answer for the given problem involving fractions. Number 1, the answer is 7/2. Number 2, the answer is 5/4. Number 3, the answer is 1/9. Remember, these are just right or wrong. Number 4, the answer is 8. Number 5, the answer is 2. Number 6 is false because it's not equal to 5. It's equal to 7/3. Number 7 is false because it's not equal to 1. It's equal to 74 over 35. Number 8 is also false, because it's not equal to 6/5. It's equal to 8/5. Okay, number 9. After I read it, I'm like, dang, this is almost like a trick question. Tommy Joe has N pairs of shoes. Daisy May has 2 more pairs of shoes than Tommy Joe. How many pairs of shoes does Tommy Joe have? That should have said Daisy May, but as it's written, how many pairs of shoes does Tommy Joe have? He has N pairs. That's the first sentence. So, number 10, John Paul's age and Mary Beth's age, when added together, equals 34. So J plus M is 34. It says they also want us to write an equation or expression. Mary Beth is 2 years older than John Paul. So Mary Beth is John Paul's age plus 2. What are their ages? John Paul is 16. Mary Beth is 18. Number 11, it just has solved the problem. The new sale price for the sweater is $57.60. Okay, so that's all for the front. Let's flip over to the back. For the first 2 problems, you're plotting points on the coordinate grid. For point A, at 3, -2. It's going to be right here. There's A. B is at 4, 0. There's B. C is at -2, -3. D is at 3, 5. E is at -1, 4. And then F is at -4, -5. There's your points. Okay, 14 and 15, your rounding numbers as indicated. 14, round to the nearest 10th. The nearest 10th would be 4.3. On part B, round to the nearest unit, which means the nearest whole number. So that would be 246. 15, round to the nearest hundredth. So 2 decimal places. 16.39. 17 says round to the nearest thousand. So that would be 1,763,000. For the next 2 problems, they want you to write the number that corresponds with the numeric statement. A says the company's liabilities total $34 million. So we're just going to write 34 million. That's a 34 with 6 zeros after it. B, the total of investments was 2.2 thousand. So 2.2, that means 2,000 and then $200. 17, part A, the population of a country is 1,700,000. That sounds confusing, but just write down what you see. 1,700, and then 1,000, we know we need to add 3 zeros after. Put your commas in. It ends up being 1,700,000. B, the cost of a new airport can run as high as $3.25 billion. So 3 billion, and it says 3.25. So 3 and 250 million. I need to add enough zeros to make sure that's going to be 3 billion. There we go. Three and a quarter. For the last three, we have to just answer the following questions. If there's no solution, indicate it and provide a reason. 5 divided by 0 is undefined. That is our answer. Why? We can't divide by 0. Tommy Joe is driving 60 miles an hour. Is he traveling 1 mile per minute? Yes, he is. Just real quick to illustrate why, if you have 65 miles in 1 hour, and you want to convert that to miles per minute, well, in 1 hour, there are 60 minutes. The hours cancel, 60s cancel, so you're left with 1 mile per minute. And then the last one, which number is greater, -9 or -900? Well, with negative numbers, it's the opposite. So the smaller looking number is actually the greater number. -9 is greater than -900. Okay, so on the top of the front, put how many that person missed and pass it back to them. This test is not going to go in the grade book as it is. This is just to give you an idea and give me an idea of what we kind of need to work on as the semester goes on if you were to stay in dual credit finite. So if you get it back and it says you missed 15 of the 20, I mean, that means we're going to have to put in quite a bit of work this semester, but it's doable. Or you may say, I don't want to put in that much work. It's my senior year. Get me out of here. Okay, I don't want you to leave, but if that's how you feel, so be it. But anyways, once you take a look at yours, pass it up and give it to the sub. And then get out your notebook for today's notes. I'll give you all a few minutes to do, I say a few minutes, a few seconds to do that. Okay, let's move on to our notes for today. So today is going to be our first day. We're going to look at the real numbers. So the real number system, and then kind of talk about some basics. So hopefully the sub has passed out your assignment. I'll say it's like 20 questions. She's passed that out. Like I said, that'll be done in Edulastic. By the time you watch this video, I'll have the assignment made. I just don't have it made to show you like ahead of time. So on each question, you'll get 2 attempts. So you can like type your answer in, click check answer, and you can do that twice before it just says, okay, you've exceeded your checks. And my goal on most of these homeworks is for y'all to get, or really all the homeworks, for y'all to be able to get hundreds on them. That way you have hundreds for your daily grades. But that means you're going to have to put in effort. So, anyways, section 0.1, the real numbers. We're going to start off by kind of drawing a diagram, if you will, of all the different numbers that we have within the real numbers. So kind of start by drawing like a big box. Okay, so at the top of this big box, I'm going to just write real numbers because everything in here is considered a real number. Now, real numbers can be divided into two different types of numbers. The first type, let me get some more pins up here. Let me the green there. What happened? Add a pin. Make it green. Move it over there. There we go. Add another pin. I'm gonna make it blue. And then move it over there. Okay. So within the real numbers, we have two types. We have rational numbers, which rational numbers are those that can be written as a reduced fraction. Like they have an endpoint. We may not know their endpoint. Their endpoint may be 100 digits past the decimal point, but they have an endpoint. An example would be like the decimal 1.25. That can be written as 5 over 4. It's written as a simplified fraction. That's a rational number. Our other type of real number is an irrational number. Irrational numbers go on and on and on forever. They don't have an end. So irrational would be like if you did something like, I don't know, 11 divided by 9. That would give you 1.11111. It's never going to end. It's just going to be ones going on forever. That's irrational. Another example would be like pi. 3.14159, and it keeps going. Last one is E. Well, not the last one, but another one is E. 2.71828, and then it keeps going, kind of like how pi would. Those are irrational numbers. The way I like to think of it, an irrational number, what do you think? Now, they have a reason they're saying it, but as a teenager, what do you think your parents are often being when they get on to you about something? You think they're being irrational. Like, come on, mom, okay, I get it. Just, you're being irrational. You're blowing it out of proportion. They have their reasons, but in your mind, you're like, oh, she's just going on and on and on. Okay, I get it. Enough. That's irrational. At least in your teenage brain. Okay. Within the rationals, we're going to draw another rectangle. And those, we're going to call those, let's see, integers. So these are going to be integers. Now, integers are rational numbers because if I were to write the number 3, integers are like whole numbers. Well, integers include whole numbers. Let me not say that. But if I write the number 3, that's the same as saying 3 over 1. So yes, an integer is a rational number. But your integers mean there's no decimals with them. So like -3, -2, -1, 0, 1, 2, etc. Those are integers. No decimals with them. Within the integers, you have your whole numbers. Within the integers, you have your whole numbers. Those are going to be your positive integers, including 0. So 0, 1, 2, 3, etc. And then within your whole numbers, you have what are called natural numbers. So your natural numbers are like your counting numbers. That would be this group right here. Those are natural numbers. That's kind of how the real number system is broken down. Like real numbers cover both rational and irrational. Within rational, you have your integers, then your whole numbers, and then your natural numbers. Okay, so let's kind of look at some properties of real numbers. Properties of real numbers. There's several properties we want to talk about. There's actually 5 to be specific. One of them is called the distributive property. I know y'all are familiar with this one. This is the one that says if you have something like A times B plus C, that would equal AB plus AC. Because we take this A and we distribute it into the parentheses. That's called the distributive property. Another one is called the commutative. Think like commute. It can move. The commutative property. If you have something that says A plus B, that's the same as saying B plus A. It's commutative. You can switch them around and get the same answer. Another one that's commutative is also multiplication. You can have A times B, and that's the same as saying B times A. Multiplication is commutative. Then we have associative. Think of associative as like who you associate with. We have A plus, and then B and C go out together, and they're in parentheses. Well, that would be the same as if A and B left and then met up with C. Either way, A, B, and C are all at the same place. It's just who rode with the other. In the first case, B and C rode together and met up with A. In the second case, A and B rode together and met up with C. They all ended up at the same place. It's just who rode with the other. Multiplication is also associative. We could say A times B times C. Well, that would be the same thing as saying A times B times C. So, furthermore, we can take it a step further. This example is also commutative because I could say A times B times C is equal to B times A times C. So multiplication is both commutative and associative. If you're just multiplying everything together, it's both commutative and associative. Okay, let's look at some more properties. We've got two more left. As far as properties go, you got the inverses. The inverse property says that A plus negative A is equal to 0. And then you have the identity property. A times 1 over A is equal to 1. Or another way you can end up saying that is A times 1 equals A. That's the identity property. So those are your properties of real numbers. Another thing that involves real numbers that you've talked about before in your other classes are the order of operations. So normally, when you do order of operations, you think PEMDAS. That's how we used to do it. Like, that's how I learned it. PEMDAS. Please excuse my dear Aunt Sally. Parentheses went first, then exponents, multiplication and division were kind of together, and then addition and subtraction were together. But I know now y'all don't call it PEMDAS, you call it GEMS. You do things that are grouped together first. Then you do your exponents. These two come together for multiplication and division. And then these two go together for addition and subtraction. So whether you call it PEMDAS or GEMS, it's still the same concept. You do parentheses, then exponents, any multiplication or division, and on that you have to go from left to right, and then addition and subtraction, again, left to right. All right. Then we've got inequalities. What does this sign mean? That means less than. If we put a line under it, that would mean less than or equal to. Well, let's flip it around. If it's facing the other direction, that means greater than. So the number on the left is bigger. Greater than or equal to, if it has the line underneath. And then another inequality is, well, the not equal sign. That means not equal. For the less than and the greater than, a memory trick that I like to show those that are still trying to get them straight. Think of it this way. This then, and then I feel like this is kind of backwards, but greater than. Okay, there's your inequalities. Think about graphing on a number line. I know y'all had to do that in Algebra 1 and Algebra 2. Let's kind of remember how to graph our solutions on a number line. Okay, so if we just said x is going to be less than 5, and you were told, hey, graph that on the number line, we can draw our line. And then I like to put where 0 is, so I'm going to put 0 here. Maybe 5 is going to be over here. Okay, less than 5. Remember that sign means less than. So since there's no equal to, I'm going to put an open circle over the 5. Not to be less than that. So I would shade to the left. Less than is left. That's the way you can remember which way to shade. Less than is left. And put a big old arrow. I've graphed that one. Let's do something like -2 to 5. So that's how your solution was written. Let's get our number line in here. Well, I know 0 is going to be here. Negative, this is 5 all the way out here. Maybe -2 is like right here. Okay, so the way you could do this is since the -2 has a parentheses, let's put a parentheses at -2. 5 has a bracket. Why did it do that? Come back. There we go. 5 has a bracket, so we're going to put a bracket at 5. And then we're going to just shade in between. There's your solution set. I think the computer's tired. It's telling me I need to hurry up. I've been working on some school stuff all day. Okay, what about something like x greater than or equal to 2? Okay, so here's going to be there. Choose there. So since it's greater than or equal to, I'm going to come to my 2 and put a closed dot. Since it has the equal to, I want a closed dot with undoing everything I just did. And then it's greater than, so I'm going to shade to the right. And then put me a big old arrow saying I would keep going. And then the last number line example, let's say we go to infinity, but we do like 2 to infinity. Something like this. 2 to infinity. So it looks like it's the same thing, but now we're using parentheses and brackets versus the normal, like inequality symbols. So we're not going to do the dots anymore. Now we're going to have to do the parentheses. And since it's a parentheses, that means we don't even include the 2. That's where we put our parentheses, but our solution set doesn't include that 2. So we'll put a parentheses at 2, and then we'll shade to infinity. To infinity and beyond! And our last topic for this one is absolute value. Absolute value. Absolute value is the distance a number is from 0. If you had positive 9, you took the absolute value of positive 9. But how far is positive 9 from 0? It's 9 away from 0. You get the same answer if you did negative 9. Because remember, absolute value is just the distance a number is from 0. It's not saying whether it's above 0 or below 0. How far is it? Well, negative 9 is still 9 away from 0. So remember, absolute value, it's always going to be positive. If you had something like the absolute value of negative 1 minus 3 inside the absolute value, you would evaluate that first and treat it like parentheses, and then take the absolute value. So this would be the absolute value of negative 4, which would be 4. So you evaluate first and take the absolute value at the end. Okay, so that's all for this lesson. Again, the sub should have passed out the assignment to you. It's going to look something like, let me find it. Your assignment will look something like this. So start working on that, and then you'll have to report your answers in Edgelastic. Don't try to turn in the paper for me to grade it. I'm not grading it. Put your answers in the Edgelastic. That way I don't have to grade anything. It'll grade it for me, and it'll grade it for you. That way you know what you got right and what you got wrong. So anyways, that's it for today. The one thing I want you to remember is that you are loved, you were created to do wonderful things, and you are awesome. Always believe.